once again to the channel. So here we are going to solve this exponential equation under indices. And so questions of this nature, they lead to quadratic equation. What you will realize that this expression in the second term, that's 2 to the power x, you can get that same expression in the first term here. And so the first term is the concept from indices that if you have 2 to the power, let's say a to the power m times a to the power n should be equal to a to the power m plus n. And so this is a product of 2 to the power 2x times 2 to the power 1. And so we write it to 2 to the power 2x times, let me use this dot, times 2 to the power 1. And 2 to the power 1, of course, will be 2. So we leave it like this, minus 5 bracket open 2 to the power x plus 2 is equal to 0. So having done this, then if you have under indices another concept, you have a to the power m n. This can also be written as a to the power m or to the power n. That is, you can factorize out one of the values of the power or the product of the power. You can factorize it out to suit your solution. So here we want an expression of this nature, 2 to the power x, and from here we can factorize 2 out, and if you factorize 2 out from the power, you are left with 2 to the power x. And so here 2 times this, you can bring the 2 forward, this 2 forward, then we come and factorize the 2 out of this. So we are left with 2 to the power x all to the power 2. If you factorize the 2 out of this, minus 5 bracket open 2 to the power x plus 2 is equal to 0. So at this stage, you have 2 to the power x here, 2 to the power x here. So what you do is get a common variable to represent 2 to the power x. So you can say let y be equal to 2 to the power x. Now, if y is equal to 2 to the power x, then it means wherever we see 2 to the power x in the expression, we put y. That will substitute y in place of 2 to the power x. So we're going to have 2 times bracket open y all to the power 2 minus 5 bracket open y plus 2 is equal to 0. So if you substitute y in place of 2 to the power x, you are going to be left with 2 times y to the power 2 minus 5 times y plus 2 is equal to 0. At this stage, you simplify. So 2 times this will give us y squared. So 2 times y squared will give us 2y squared. This will be 2y squared minus 5y. That is 5 times y plus 2 is equal to 0. So here you have a quadratic in y. So solve for y. So here you can either use the factorization method of completing the square. You can use the quadratic formula, that's the general quadratic formula. But here use the one that will be easy for you. So let's use factorization method. So we have 2y squared minus 4y minus y plus 2 is equal to 0. For factorization method, this is what we're going to have. Now, you factorize a common factor from here, and you common factor from it. So here the common factor is what? 2y. So factorize 2y out. If you factorize 2y out here, it will leave with y minus, if you factorize 2y out here, it will leave with 2. Then you factorize a common factor. The common factor here is negative 1. You see, whatever is going to be left after you have factorized out the common factor, it should be the same as y minus 2. So here, if we take out negative 1 from here, we're going to be left with y minus 2, which is equal to 0. So whatever you are getting after you have factorized the common factor in the first 2 terms, it should be the same thing that we get in the second 2 terms. And so this will be equal to 0. So having done that, you see that y minus 2 becomes a common factor between this term and that term. So factorize that 1, 2 out. So we have y minus 2. So if you factorize y minus 2 out of this, you are left with 2y. minus, if you factorize y minus 2 out of this, you are left with the 1 here is equal to 0. So what it means is that either your y minus 2 is equal to 0 or your 2y minus 1 is equal to 0. So in that case, we solve for y. So here we're going to have y is equal to, you have 2, positive 2, that this should group like terms here. Or here you have 2y is equal to 1. And here we can still simplify further to get y by dividing both sides by 2. So here by 2. This will cancel that, leaving your y to be equal to 1 divided by 2. But don't forget, we said our net our y is equal to 2 to the power x. So you bring back your 2 to the power x. You are looking for x here, not y. You have just introduced the y to get your quadratic equation out of this exponential equation. And so if y is equal to 2x, you bring it back here. But your y is equal to 2 to the power x. And so if your y is equal to 2 to the power x, then it means considering the first solution for y, that is at y is equal to 2, then it means if we bring 2 to the power x in place of y here, we're going to have 2 to the power x is equal to 2. And any number to the power, so this one, it means the bases are the same. Here the power of this 2 is 1. Any number to the power is 1. And so if the bases are the same, then the exponents are also the same. So x will be equal to the 1 here. And so we're going to have x is equal to 1. Then the other one, if at y is equal to the other solution, 1 divided by 2, then bringing 2 to the power x in place of y, we have 2 to the power x being equal to 1 divided by 2. So 2 to the power x is equal to, if you have, under indices, if I have this can also be written as 2 to the power negative 1. That's one of the concepts of indices. But if you have a number to the power negative 1, the same as 1 divided by that same number. So we will write 1 divided by 2 to 2 to the power negative 1. And so here, once the bases are the same, we can equate the exponent. So our x is equal to minus 1. Therefore, our x is equal to positive 1 or our x is equal to minus 1. And that is the solution set or the solution for this exponential equation. Continue to subscribe and share for more videos. Thank you for watching.